Today, my topic is to discuss alternating current circuit containing resistor, containing capacitor, and containing inductor. First of all, we'll see uh, when AC circuit is connected a resistor only. Okay, one by one we'll discuss. First of all, we'll see the effect of AC circuit when it is connected only resistor. Okay, so as you know, when a resistance is connected in a circuit, it will offer resistance to the flow of current. যেতিয়া resistor এটা connect করা হয়, let us consider a resistor R is connected in series with an AC source of EMF E is equal E naught sine omega t as shown in figure 1. So let us connect a resistor R in series, okay, with an AC source. Mind it, it is not DC source, it is AC source. It is why. So we are writing like this. This is key, and this is not DC source. If it is DC source, we'll write like this. Okay. DC source means it will change current continuously in the same direction. Okay. But we are not connecting DC, we are connecting AC. So the source is this alternating. There is no definite positive sign and positive negative sign. So because alternating current always changes. Alternating current always changes its direction, positive and negative. So at all time it changes its direction. That is why we cannot give that any directional motion of current. একেটা দিশতে কারেন্টটো নাযাব, কারেন্টটো এবাৰ এফালে যাব এবাৰ এফালে যাব। সো পিৰিয়ডিক্যালি মানে হি কারেন্টটো চেঞ্জ হৈ থাকিব তাৰ ডাইৰেকশন। আমি কৈছিলো অল্টাৰনেটিং কারেন্ট মানে হল the magnitude changes continuously and direction changes periodically. That is the alternating current, right? So we are giving EMF E is equal to E naught sine omega t, right? So therefore the AC, so alternating current when R is connected, so following Ohm's law is equal to V is equal to IR, so E is equal to IR, right? According to Ohm's law, this is voltage, current and resistance. So E is equal to E naught sine omega t IR. So we are in need of current. Suppose I. This is equation number 1. I is equal E naught by R sine omega t. Okay. I is equal, dividing left hand side by R will come this side. So E naught by R sine omega t. Okay. So let me write here. Therefore, I is equal I naught sine omega t. So you see this value where I naught is equal E naught by R. E naught by R, the peak value of current, peak value of AC, peak value of alternating current. So from this relation, this is equation number 2. from this relation we can see that I naught is the relation between I naught and E naught. Okay, so E naught is greater than I naught. Is it? When E naught is divided by R, you will get I naught. It means that E naught, the peak value of EMF, is greater than peak value of current. Right? Now, equation 1 implies, this is equation 1, E is equal to E naught sine omega t. Right? E is equal to E naught sine omega t. Equation 2, I is equal to I naught sine omega t. Right? Both are in phase. Both are in phase. So if this represent E naught, I naught will be the same, but I naught will also change according to E naught. Mane sin omega t yato ase duita eke phase ase kunba tat angle to besi hoi thoka nai jodi enaka holoten ami koloten je phase eke phase nai yar phase to besi hoi ase enake koloten. So now we observe that sin omega t and sin omega t, here also sin omega t, here also sin omega t. That is why we can say does E and I are in same phase. Phase means dokha. Okhomia dokha boli kobo. Phase, same phase. Eke phase thakibo as shown in figure 2. This is figure 1. So if we draw the figure 2, how we will write? This should be in same phase. Suppose I'm drawing E first. Okay. E is increasing. Here it is E naught. Okay. E and I in the x direction or y direction, and omega t in the x direction, right? So from 0, this is following the sinusoidal rule as increasing, decreasing, again increasing in opposite direction, again decreasing, again increasing in positive direction. So this is the nature of sinusoidal curve. So the EMF varies like this. Now what about current? Current to ki hobo? Current to kenake vary koribo? Eke dhorone vary koribo. Khali ami dekhiso je I naught and E naught are not equal. Yotor peak value kita eke nohoy. So eta peak value kom, I naught is less than E naught. E naught divide korile mane he ami I naught pam. So I naught, this represent E. Okay, and if we draw I, it will be in the same phase, but slightly the peak value is slightly less than E naught. So this is I naught, right? Can you understand? This second curve represent I, that is I E naught sin omega t, and this is I naught sin omega t. Okay, you can give dotted line also. The second graph for I, you can give dotted line so that you can easily recognize the curve. So dotted line curve represent the variation of I. Its peak value is less than, okay, its peak value is less than E naught, less than EMF. So they are varying like this. You see, from 0 they are starting, they are getting the peak value at the same time. That is called phase. They are getting the peak value when it is 90 degree. they're decreasing, both I and E are decreasing to 0 at the same time. একে সময়ত সিহঁতি 0 হ'ব. Again, they will increase in opposite direction and decrease to 0 at the same time. Time period again. That is why it is called they are in same phase. That is called it is same phase. একে দশাত আছে. এটুকে কোৱা হয় একে ফেজত থকা বুলি. So I think you can follow this. This is called phase. They are in phase. Should be equal. Okay. The dotted curve represents the current curve, alternating current. The full line curve represents the EMF, alternating EMF curve. So in this way, we can discuss when AC circuit contains only resistor, then it behaves like this, and peak value of EMF is greater than peak value of current, and both E and I, EMF and current, are in same phase. That is, it offers resistance, right? So what is resistance? The resistive opposition to the flow of current is called resistance. Okay. In the next, let us see resistor is okay. Now let us see AC circuit containing inductor. Okay. Next, AC circuit containing an inductor coil only. Okay, an inductor coil only. So what will happen? Let us see. Let an AC source E is equal E naught sine omega t is connected in series with an inductor coil of inductance. As you know, what is inductance? Inductance L, that is self-inductance. Okay, shown in figure 1. So let us see, this is an inductor coil. Okay, so it is connected with an AC source with a key. The current will pass through. The inductor coil has inductance L. Right. Now, due to self-induction, the EMF induced in the coil is given by minus L di by dt. Okay, so when L comes, suppose this is E dash, okay, E dash, the negative sign comes due to Land's law. So therefore net EMF in the circuit equal E minus E plus E dash. So this is net EMF. E is the EMF connected here. This is source, and E dash is the EMF induced in the coil. As you know, this EMF is always opposes this source. So negative sign is there. So E is equal E minus L di by dt. Okay. According to Kirchhoff's rule, if you apply Kirchhoff's second rule here, there is no resistor. So total EMF is equal to the product of current and resistance, because there is no resistor. That is why this EMF will be equal to 0, because there is no resistance. What is the Kirchhoff's second rule? Second rule is that the product of current and resistance or voltage drop in each branch is equal to the algebraic sum of the EMFs. Here only EMFs are there, no resistor is there. That is why this side is 0, this side is 0. Only EMF is there, right? So from this equation, what we get? From this equation, we get that E is equal L di by dt, right? So if you put the value of I, as you know, the value of I is equal to what? I naught sine omega t. I naught sine omega t. Okay. So if you put the value of I here, so now you have to differentiate I naught sine omega t. What you will get? I'm writing here E is equal, L is there, I naught will be there. If you differentiate sine omega t, what you will get? Cos omega t and omega cos omega t, right? So E is equal E naught sine omega t plus pi by 2. Whether we can write sine omega t plus pi by 2 in place of cos omega t? Yes, we can write, because we know that we know by definition that sine 90 degree plus theta is equal what? Cos theta. Second quadrant. Okay, if it is second quadrant, 90 plus theta, because it is 90, it is multiplied by odd number. That is why sine becomes cos, and it is plus because second quadrant. This angle is second quadrant. That is why it's cos theta. Following the same rule here, we are getting this. In place of cos omega t, we can write sine omega t plus pi by 2, right? So E is equal where E naught is the L peak value of EMF. Peak value of EMF. Okay, this is the peak value of EMF. From equation 1 and 2, what we can observe? The AC is given by now, since I is equal I naught sine omega t, okay, this value, and E is equal E naught sine omega t plus pi by 2. So both E and I are not in phase. They are not in phase. Thus I and E are not in phase. The phase of E is excess by pi by 2. Okay, E leads I by phase leads I, that is EMF leads current by pi by 2 radian in phase. Okay. If you saw the figure 2, that if you draw the phase, suppose this is okay, this is EMF. Okay. If you draw the current, then current will be less than when EMF is 90 degree, peak value, EMF gets peak value, then it becomes this. Okay. So slowly it will lead this. Because current is always less than, the peak value of current is always less than EMF. Okay. This gives EMF and dotted line gives current. This figure 2, right? So in this way we can observe that when inductor coil is connected with alternating circuit, then both current and EMF are not in phase. Yeti phase of nethakibo. Karon omega t hole et omega t plus pi by 2 90 degree phase of ag bai thakibo.